Hello guys, my name is Ted, as you guys know. The topic I want to tell you is about ideal gas law. This sounds like more chemistry or thermodynamics, but science is all related to each other. So I'm gonna talk about ideal gas today. And both today and the next class, I'm going to explain about what ideal gas law is and the phenomenon of ideal gas law. And especially for today, I'm going to mention the basic concept of ideal gas law and what kind of equation in the ideal gas law and how many variables and what kind of variables are in the ideal gas law. It's going to be very easy and simple. Let me see. First, the ideal gas law is the equation of state of a hypothetical ideal gas. And from here, ideal gas is a theoretical gas which is composed of a set of randomly moving and non-interacting particles in the gas. And this ideal gas law is very useful to understand the behavior of gas under given conditions like pressure, volume, and the temperature. So the equation for the ideal gas law is PV is equal to nRT. So from here, P stands for pressure, the V stands for volume, and the N stands for the amount of moles, amount of particles in the gas, and the R stands for gas constant. That's just a experimentally defined constant. And the T is temperature. So let's look at more specific variables in here. So from the equation, PV is equal to nRT. P is pressure acting on the gas, and which is in the unit of Pascal. Pascal is the Newton per meter squared. And the V is the volume of gas, which is the unit of liter. And the N, N is the amount of gas molecule, and is a unit of mole. I guess many of you guys not quite familiar with the terms mole, because the mole is a measurement used in the chemistry field to count how many particles like molecules and the electrons, atoms. So mole is, we can use Avo, I'm not sure the name of the scientist, Avogadro, whatever. The mole is the very huge number, like a 6.02 times 10 to 23rd. So it's very huge. So if we have a 6.02 times 10 to 23rd molecules or electrons or atoms, we can say that is 1 mole. So if we have 10 mole, that means 6.02 times 10 to 24th. Does that make sense? Okay. So the next R is a gas constant, which is like I said, just constant defined from the experiment, and the T is temperature. But the temperature here is quite different from the temperature we know in our life. Usually we use Celsius degree or Fahrenheit degree, right? But in science field, we usually use absolute temperature, the Kelvin, the K stands for Kelvin. The absolute temperature is like we define the temperature in the science field. We can say zero Kelvin as a negative 273.15 Celsius degree. So in our life, the room temperature is like a 25 Celsius degree. That means almost 300 Kelvin. Okay. So let's talk about how this equation works. Let's assume we have a container with these 8 molecules here, and there's a piston in the container. When we as you can see, the equation PV is equal to nRT, and this system, this is called the equilibrium system, and the temperature is, for the three system, the temperature is equal, and the number of molecules is equal. When you press the piston down, it's gonna be the V is gonna be decreased, and then to make sure to satisfy the constant value of nRT, the pressure is going to be increased. Okay, and then the other way, if you put the piston up, it's gonna make more volume in the container, and that means the pressure is going to be decreased. And or if you can heat it up, that makes the particles or molecules move faster, and they're moving around very fast. That means that there's going to be more volume in the container, and that means less pressure in the container. So this is pretty much about the ideal gas law, and this is quite easy. And for the next presentation, I'm going to give you a more practical example of ideal gas law we can apply in our daily life. So next time will be more interesting. So that's it. Is there any question? Okay. Thank you.